Hello, my name is Shivam. In this video, I will be presenting two mechanisms that are used by botnets to protect CNC components. First, let's talk about domain generation algorithms. In domain generation algorithms, we create a large number of domain names, which are created periodically. And these domain names, they can be used to communicate with the C2 servers. So let's try to understand this process with this following diagram. So let's say there is a malware and there is a C2 server who wants to communicate with each other. So the malware must use some domain name to communicate with the C2 server. Let's say it uses DN1 and DN2. So we have these options. So a malware can choose DN1 to communicate with DN2 if that domain name is available or it is unblocked. Now let's try to understand why we need a large number of these domain names. So for the communication, we only need one domain name. So why do we need all of these domain names? We need the other domain names because using these large number of domain names, the C2 structure would become more resilient. How would it become more resilient? Because if malware is using only one domain name, and if somehow this domain name is pinpointed by the security experts, so they know that this domain name is being used for the communication between malware and C2 server, so they can easily block this domain name to stop the communication between malware and C2 server. In those circumstances, uh, the adversary should have some other option or some other way to carry on the communication. So if they have some other options like some other domains, they can just use the other domains to carry out the communication. Okay, and this way the structure becomes more resilient. Even if the domain name 1 is blocked, they can still use the other method, which is domain name 2, to carry on the communication. Now the other reason is this allows for dynamic rotation over the domain names. Now, why would we need to dynamically rotate over these domain names? Because this is going to help avoid detection. So the idea is we switch over these domain names very frequently, and frequent switching of domain names is going to allow very less time for the security professionals to track down the communication. And because of that, we use a large number of domain names to just frequently switch over these so that the security professionals don't get sufficient time to track down or to avoid to detect the communication. Now let's try to understand the process using this diagram. So first of all, for this process to work, the DGA algorithm and seed must be present with the attacker and malware. Okay, so they should have the same DGA algorithm and seed. So this would enable both of them to generate same domains. The attacker will choose some of the domain names and point those domains to the C2 servers, and then the malware can easily just use these domain names to set up the communication channel between the malware and C2 server. And this process can be understood with this following diagram. So in this diagram, first of all, we should notice that the same DGA and seed are provided to both malware and the attacker. And then using the domain generation algorithm, they can generate these domain names. And let's say that the attacker registers this domain name. So now this domain name is going to correspond to the C2 server. So when the infected host tries to reach out to these domain names, the first three domain names don't work because they are not registered. But when they query for the fourth domain name, they get a response, which is the IP address of the CNC server. And then using this IP address, which they get from the DNS server, they can set up the communication with the C2 server using that IP address. Now let's talk about fast flux. So it is a DNS technique which involves frequent and rapid changing of IP addresses, which are associated with a particular domain name. And this process uses a network of compromised hosts which act as reverse proxies. And this process can be understood with this diagram. So malware needs a domain name to communicate with the C2 server, but here the domain name is mapped to a number of IP addresses. So let's say it is mapped to IP1 and IP2, and these IP addresses are of the bots in the botnet. So using this IP address, this IP address can be this corresponds to a particular bot, and then the bot can process the query to the C2 server, which is going to reply the response back to that bot, and that bot is going to give the results back to the malware. So that's how the communication works. But here, after a certain period of time, the domain name is going to map to some different IPs, which are going to be the IPs of this bots in this botnet. Now let's talk about how does changing IP addresses protect CNC components. So rapid and dynamic change of IP addresses associated with C2 server, they make it difficult for security experts to pinpoint and block the location of C2 server. Now, why does it make it challenging? Because if we are dynamically changing over the IP addresses very frequently, then the security experts have less and less time to detect the location of the C2 server. And because of that, this kind of process is very efficient at hiding their location or going undetected by the security experts. So because of that, this process also allows to avoid IP blacklisting because C2 server is running behind the botnets. Now let's talk about two types of flux networks. First, single flux networks. So in single flux networks, we frequently change IP addresses associated with the domain name. And how do we change the IP addresses? We change these by updating DNSA or DNS4A records for the domain. These DNSA records are responsible for mapping a given domain name to IPv4 address, and 4A records, these are responsible for mapping a domain name to IPv6 addresses. And in single flux networks, we have low TTL values, which means that we are going to change the IP addresses of the domain name very frequently. And so when a TTL value expires, IP address is going to change. And let's try to understand this process of single flux networks using this diagram. So first of all, we notice that the CNC server updates this domain name with these two. It maps this domain name with these two IP. So when a malware tries to figure out the IP address of a given domain name, it's going to send the request to the recursive DNS server, which is going to go to the root server, and root server is going to redirect this to the .com name server, which also redirects to authoritative name server. And in this authoritative name server, this domain name has been mapped to this IP address and this IP address. So it gives the response back, and the response is these two IP addresses. And once the recursive DNS receives the response, it's going to give it to the malware. So now malware has these two IP addresses, so it can use one of these IP addresses to connect with the C2 server. So it can send an HTTP request at this IP address, which is the IP address of this Flux agent. And after receiving the IP address, it can send it to the C2 server, and C2 server is going to respond with some reply, and this reply is given back to the malware. So this is the process of single flux networks. Now let's talk about double flux networks. So as compared to single flux networks, here we change both IP addresses of domain names and authoritative name servers. And this is also done very frequently. So that is the only difference, that here we change the domain name and we map the domain name and authoritative name servers to the IP addresses of one of the bots in the botnet. And this is done by updating the DNSA and DNSNS2 records. And so again, we update the domain name and authoritative name servers and assign the IP addresses of one of the bots in the botnet. In double flux networks, again, we have low TTL values, so that we very frequently change the IP addresses of domain names and authoritative name servers. And when the TTL expires, the IP address is going to change for both of those. So let's try to understand this process in the following diagram. So first of all, we notice that the attacker has done two things. So first of all, it has changed the domain name, and this domain name is mapped to this IP address, which is the IP address of one of the bots, which is this bot. And secondly, it has updated the IP address of this domain name in the .com name server, and this is the IP address. Now this IP address corresponds to this bot in the botnet. So we can see that once this domain name is queried, it's going to send the request to this botnet for getting the IP address. And now the process starts at malware. So when the malware is going to ask for the IP address of this domain name from the recursive DNS server, the recursive DNS server is going to ask root server. Root server is going to direct this query to .com name server, and in .com name server, this domain name has already been assigned this IP address. So now the .com name server is going to redirect this to the botnet because of this updation in the .com name server. And once the bot receives the request, it's going to go to the C2 server, and C2 server is going to respond, and it responds with the IP address of a bot, which is this bot. So now this bot is going to reply with this IP address, and this IP address is given by the recursive DNS to the malware infected host. And then the malware infected host sends an HTTP request to this IP address, which is corresponding to this bot. And after receiving the request, it's going to send the request to the C2 server, which is going to send the reply back to the bot, and the bot is going to deliver the reply to the malware infected host. And this is how the double flux networks work.